In this video, we're going to cover database indexes. We've mentioned indexes previously. They're sort of like an index in a book. Okay, but indexes are used to do a couple different things. One, they're used to increase performance. They're used to enforce constraints. Something like a unique index is what's going to force constraints. They can be composed of one or more columns. Just like we have a composite primary key that's composed of more than one column, we can also have a composite index that's usually created at the same time. And indexes, they result in better performance with selects, but they actually decrease the performance in inserts and updates because they have overhead. So let's go through and actually look at a few examples here. Let's see. If we were going to go ahead and look for a people, specific like first names perhaps, we have a choice of scanning through the whole table, or we can actually go through an index and kind of let it skip through because an index is ordered. Let me go through an example here. It's probably the best way to do it. Look at this item table. I'm going to click on structure. Down here are indexes, and an index again gets created immediately whenever a primary or foreign key gets created. So we have item ID, which is the primary key, and I have item publisher ID and item category ID. If we look at content, they got the little arrows here, so we know those are foreign keys, or we can click on relations here to other tables. But let's go ahead and say I want to find all of the, I don't know, X-Men items. I could write a select statement that says select star from items where, let's see here, it's called title. Title like, I want everything that starts with X-Men. I'm going to put a %. Again, so I'm looking for anything that starts with X-Men. If I give that a run, it runs for 28.8 milliseconds and it returns 36 rows. Now if I look at that table, I got about 24,000 rows. So that is really quick, but let's make it a lot quicker. When it searched for this filter, the title like X-Men, it actually had to read through the entire table, all 24,000 rows, and look inside of the title for each one. And by the way, these aren't ordered. They're not ordered by title, they're ordered by, happens to be item name. So it's not something that it's going to find easily. It needs to go ahead and find the third one and keep going down and find whichever else ones happen to exist. However, if you go to structure, make sure item is selected, and hit the plus button down here. I'm going to create an index, and there's two types of indexes. Non-unique, they're also called regular indexes or performance indexes. Usually I say non-unique or regular indexes. And then the other one is a unique index. Well, titles may repeat, so I don't mind. I'm going to go ahead and just leave it as an index. I don't want to force any uniqueness, and I want to make it on the title column. So when I hit add, it'll take a moment, and then down here it will say we have a non-unique index on title. Well, what does this really change? Let me rerun this. Originally it took 28.8 milliseconds. Now it takes 0.7. That's not double, it's not even triple, that's 4 times as fast. And sometimes if you run it again, it may get a little slower or quicker. The reason is, by creating an index on title, we now have like a separate column which has just titles in it, alphabetically ordered. So we can jump down to the X's, or the database will jump down to the X's, and each of those rows will have a pointer to this table row, so it knows how to get that particular row. But the important thing to know is indexes will speed up selects. However, every time I insert into this table now, I have to insert into the item ID, primary key index, this index, the category index, and now the title index. And if I do an update and change the title, well, now I have to update the index. So although they speed up selects, they slow down inserts, updates, and deletes, because an insert, an update, or a delete also has to modify the table, the indexes in addition to the table. Now, the rule of thumb is to go ahead and create indexes on the columns you search by. So if this was some type of shopping cart system, people may come in here and obviously they're going to log in, so I may index username, not just for the uniqueness, but because I'm going to search by it. But have you ever called up anywhere and say, hey, can you look up my account? And they said, sure, what's your middle name? Probably not. Middle name is something that you're never going to search by. You might verify it, but it's probably not a searchable thing, so you wouldn't index that. Something like date of birth, that may be something I verify with you, and I normally wouldn't index it if it's a shopping cart. However, if this wasn't a shopping cart, and let's say it was a database for the Census Bureau, where things are often split up by date of birth, then I would go ahead and index that. The point is, all your data is going to be different from one database to another. So if you search by a column a lot, then you want to index it. If you don't search by it, don't bother indexing it, because then it's just going to create overhead. The other point is it's also going to take up space. The users table might be 22.6 meg, but we have 51 meg worth of indexes. So currently we have more than double the amount of space taken up by indexes than we do with the actual main data. And although this may speed up with our selects, it will slow down with our inserts, updates, and deletes.